propagation of electromagnetic waves. The propagation of electromagnetic waves அப்படிங்கிறது we know that what is meant by transmission and reception. We convert that carrier wave according to the input signal. After modulating that signal, the signal wave is transmitted through the antenna. So antenna is transmitting the signal in the form of electromagnetic wave into the medium. Okay, the transmission and reception occurs in three types. Three types of propagations are there. So the three types of propagation is depending on that frequency. You can classify that. The frequency from 2 kilohertz to 2 megahertz. The frequency wave is called ground wave propagation. Then from 2 to 3 megahertz to 30 megahertz, that is sky wave propagation. From 30 megahertz to 400 gigahertz, that is space wave propagation. So kilohertz means you know that it is a kilo means 1000 hertz. Then megahertz means that is 10 to the power of 6 megahertz. Then gigahertz 10 to the power of 12. So that is the frequency of the waves. So depending on the frequency, we can classify into three type of propagations. So now we are going to see the three type of propagation. One is the ground wave propagation. Second one is the sky wave propagation. And last one is the what is the space wave propagation. So these are the three type of propagation. So first we are going to see that ground wave propagation. See, this is the ground wave propagation. So here this is the transmitter. That another one is the receiver. For example, you can take the cell phone tower. So cell phone tower is here and it's a home. You are having that cell phone. So that cell phone has the receiver and transmitter, and the same thing that antenna also has the transmitter and receiver. Here the signal is sent by the transmitter. That signal is received by your mobile phone. So here transmitting and receiving occur very close to each other. So the signal is transferred from one place to another place in a very short distance. So the signal is transmitted from here to here. So that waves are transmitted from antenna. It is slided over the earth surface. So there is no deviation in the waves. So it is glided. Glided means it's very close to the earth. It's moved from here to here. Then the propagation of electromagnetic waves. The electromagnetic waves propagate ஆகும்போது அதாவது போகும்போது there is a tilt in that propagation of wave. So tilting that wave means it has some energy. It is transmitted to the some distance. After that, that waves are decreases that energy, that is attenuation or the loss of energy, or that's called loss of energy or attenuation or distortion. That is occurs in the wave. Then finally, the electromagnetic waves are die. That means mobile phone எல்லாம் வீட்ல இருக்கிறது தெரியும். That mobile phone, the distance is 5 meter. Sir, not 5 meter, 5 kilometer. That is the range of the tower. சில டைம் சொல்லுவீங்க இங்க வந்து டவர் கிடைக்கல, இங்க தள்ளி போனா டவர் கிடைக்கும் அப்படின்னு சொல்லுவீங்க. அந்த டவர் கிடைக்குதுன்னு சொல்றது என்ன அப்படின்னா, that is the range of the tower. That cell phone is inside the range of the tower. You can receive the signal. So the ground wave propagation is used for the transmitting the signal in a short distance. Okay, here the waves are transmitted through the medium, that is air medium. It can be absorbed by the earth. That is called the absorption of the energy by the earth. Then increasing the distance. Then how we can increasing that distance? That means the range of the tower. How to increase the range of the tower means you can increase the power of transmitter, frequency of the transmitter, or condition of the earth surface. So depending on these three factors, we can increase the distance. Absorption of energy. It's a electromagnetic wave. That electromagnetic wave is transmitted from the antenna. அப்பா ஒரு மொபைல் போன்ல ஏதோ ஒரு இடத்துல மைக் ஆன்ல இருக்கு, ஆஃப் பண்ணுங்க. So signal is transmitted. That signal is absorbed by the earth. It's a electromagnetic wave. When electromagnetic wave is absorbed by the earth, then earth is an atom. You know that atoms are absorbing the electromagnetic energy. So what will happen? It produces a charge. So that is absorbing that electromagnetic energy. So absorption of energy of the earth. So some amount of the transmission, that electromagnetic waves are absorbed by the earth. And then next one is the tilting of the wave. Tilting of the wave effect means the curvature. You can see the curvature here. The curvature, it is gradually increases when it is transmitted from the transmitter to receiver. Finally, the wave is die. So the loss of the energy is called occurs depending on the tilting of the wave. So it's called tilting of the wave. So the range, that frequency range of the ground wave propagation is 2 kilohertz to 2 megahertz. So it is used in that radio navigation, ship to ship, and ship to shore communication, and mobile communication. That is from mobile phone to tower is the simplest example for the ground wave propagation. Next one is the sky wave propagation. Sky wave propagation, you can see the picture on the screen in sky wave propagation. So this is the sky wave propagation. It is a transmitter. Transmitter transmits the signal. That signal is falls on the ionosphere and it is reflected by the ionosphere. Again, the receiver receives the signal. So this type of propagation is called sky wave propagation. Before that, you should know that what is meant by ionosphere. Ionosphere means that that gas molecules are surrounded by the air. That outer surface, that is outer space. Outer space, the different rays are comes from that outer space. That is alpha ray, beta ray, or the sunlight. Different lights are comes out from the outer space to the atmosphere. So the light rays are alpha. For an example, alpha ray or the beta ray is interacted with the gas molecule. So when it is interacted with the gas molecules, means gas molecules are in neutral state. When it is interacted with that alpha and beta particles, what will happen? Ionization occurs. So it produces the ion. It emits the electron and it will become a positive ion. Like that, ions are produced in the gas molecules. So like that, it gradually increases. One layer of the gas molecules are having full of ions. So that is called ionosphere. And the ionosphere, the density of the ionosphere is not constant. For that, from it goes from Earth surface to the above the surface level for some distance. That density of the ionosphere is changes. My girls, yaar mar mic on vechukada aapanna. So it is moving in that upper layer. That it has a different density. See here, when the transmitter transmits the signal like this, that is more than the critical angle. You know the total internal reflection. Total internal reflection means above the critical angle only that light rays are reflected. Below that, it's not total there is no internal reflection. Like that, see here, that light ray is escaped from here when it is more than the critical angle. So that the transmitter is placed at a particular angle. That light rays are the electromagnetic rays are emitted from the transmitter and it is reflected by the ionosphere and it is received by the receiver. And it is reflected in the multiple times. Then it is received by the receiver. With electromagnetic waves and it is multiple reflection is occurs and the signal is received by the receiver. So it's a total internal reflection. Only the particular direction only it will reflected. Otherwise, that light ray, that electromagnetic rays are escaped from the ionosphere. We can't receive that signal. It is escaped from the ionosphere and it is goes to the space. We are not able to receive that signal. Only the signal is reflected by the ionosphere only we can receive the signal. So this is called sky wave propagation. Here you can see that here the transmitter is here. The signal is sent by the transmitter. It reflected by the ionosphere. Here the signal is received. There is a particular place between that from transmission to the reception. There is no signal is received by the receiver. Here there is a gap. So this area is called skywave, the skip distance, skywave skip distance, or we can define the skip distance that the gap between the point of transmission to the point of reception. The distance between the point of transmission to the point of reception is called the skip distance. In that area, you are not able to receive the signal. And here you can see that area here there is from A to D. There is no signal is between that 2 points A to D. That area is called skip zone. That area you are not able to receive the signal. That area here the distance, here the area. The area which is not receiving the signal is called skip zone. The distance between the point of transmission to the point of reception is called skip distance. So this is skip distance and this is called skip zone. So above that skip zone, you can able to receive the signal. So here from Earth surface to the ionosphere from 50 to 400 kilometer that light rays are reflected and it can be traveled from up to 4,000 kilometer. We can able to transmit the signal up to 4,000 kilometer. So here the frequency of the electromagnetic waves are 2 megahertz to 30 megahertz. Only that frequency only we are using for the skywave propagation. Above that frequency, suppose you are using that more than 30 megahertz, that light rays are escaped from the ionosphere. That's why only this escape from the ionosphere. That's why only this particular frequency only used in the ionosphere. So next one is space wave propagation. So here that skywave propagation is over. Next one is the space wave propagation. Space wave propagation, you know that already. We know that what is the space wave propagation. Space means what do you remember that space? How you can transmit the signal to the space? What is the device is inside the space? Like we are transmitting the signal. So here this is a transmitter. Transmitter directly send the signal to the receiver. So the receiver receives the signal. It is a two types of we can receive the signal. One is that rays directly received by the receiver. Another one way is reflected by the earth surface. We can receive the signal. Here you can see that it is a curved surface. Curved surface, we are not able to send the signal straight. By using that high frequency wave, that electromagnetic waves are traveling in the straight line. But here, Earth is a curved surface. So we are not able to send the signal straightly. That's why we are sending the signal into the satellite. Then the signal is sent into the receiver, that ground surface. You know the DTH. DTH, we are having the receiver. So for an example, you can take the Sun TV. Sun TV send the signal through the transmitter to the satellite. Satellite receive the signal and it is sent into the signal to the ground station. Ground station, we are having the DTS. Through the DTS, we receive the electromagnetic waves and we are using the signal. So it's a method of using the space wave propagation. So the space wave propagation we are using in the television broadcasting, satellite communication, radar. These are all the uses of ground space wave propagation. So here we can use the larger bandwidth, high data, better directivity, small antenna size, low power consumption. These are all the uses of the space wave propagation. So space wave propagation, what is the amount of distance covered by the space wave propagation? We can calculate it from the formula. That is D equal to root of 2RH. You know that last year 11th standard is studied in the 5th lesson. Okay. In that D equal to root of 2RH, where R is the radius of the Earth. Radius of the Earth, you know that 6,400 kilometers. H is the size of an antenna. And the D is the distance. So using the formula, you can find out that distance covered by the space wave propagation. Okay. Already we can finish that. So ground wave, sky wave. Now we will complete the space wave propagation. Then